good. So, hi. Perpendicular bisectors. I'm going to have a perpendicular line. Perpendicular lines are everywhere. In my classroom right now, the ceiling has a ton of perpendicular lines because it's just a corner that makes 90 degrees. So I might have a window, a door. I mean, it's the corner of every room in your house. I guarantee that when your house was built, they did not make the corners of your bedroom have like a round or have like a diagonal cut through the corner. So perpendicular, right angles, corners, etc. All right, so I can move up a little bit so I can get more space in. And I think I'm probably, yeah, I'll go as big as I can. Okay, so perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, so that means this point C lies on line D, then it is equidistant from the endpoints of the segment. So I know that line D is the perpendicular bisector of AB, and perpendicular bisector means that it makes 90 degrees. And perpendicular bisector means it bisects, cuts into two equal parts. So this theorem says you have this line and it makes the perpendicular bisector. Then I have a point on the line, point C, let's say. The theorem states that I can draw two lines that are equidistant to the endpoints of my bisector, equidistant from the endpoints of the segment, okay? So that means that if CD is the perpendicular bisector of AB and AD is congruent to DB, you know, I would have gone AD, BD, but then CA, segment CA, is congruent to segment CB. It made a triangle and the hypotenuses are congruent, basically. So it's just saying you can draw a hypotenuse for both hypotenuses that are congruent. Okay, so first thing I have is I know that I have a perpendicular bisector. The second thing I have is that two hypotenuses can be drawn. And those hypotenuses are going to be congruent. So that's the ordering. And the reason that I'm putting a 1 and a 2 is because now I'm going to talk about the converse, which is flipped. First thing I know is that I have a point that is equidistant. So first thing I have is a point C that has two equidistant, I'm going to call them hypotenuses, but they're just really long segments. What am I saying? Two equidistant from the endpoints, lines. So in the converse, I'm told, hey, there's these two lines that are equal distant from the endpoints of a perpendicular bisector. Then it is on the perpendicular bisector of the segment. Line C is the perpendicular line sector. I guess CB is the perpendicular bisector. So I'm making a triangle. This whole point of these two theorems are that I'm able to make a triangle. The hypotenuses are congruent. The base legs are congruent. And obviously, their reflexive property congruent as well. So I'm making congruent triangles here. Just from two lines. So CD, and CD is actually a line, because look at the arrows. CD. Put arrows at the end of CD, please. CD is the perpendicular bisector of AB, which AB is just a segment because it starts and stops. Also, that means that AD is congruent to BD.
Mrs. Grant?
Yeah.
Would you mind repeating what you wrote down on the right side?
Yeah, because I have to finish it too. The perpendicular bisector theorem straight for you is, and I'll just say it like this. I have a perpendicular bisector. I can make a point from, like, let's say where my nose hits my finger. So right here, I can draw a line from here that goes down and down, and it's going to make two equidistant lines. But you start off with the perpendicular bisector. Here, I start off with a line CD, and I have two equidistant sides. These are my hypotenuses. So here's the converse. I have a point C that has two equidistant lines or hypotenuses from the endpoints. Equidistant, equidistant, black. Then look what's made. It makes a perpendicular bisector when I draw the line. Step 2. Well, it says it, like point C. Oh, fine. Point C is on the perpendicular. I'm not going to write the word PER, I'm going to write this symbol. This symbol is an upside down T, and it means perpendicular. Of AB. So there's the regular and the converse. Okay, I want to leave these on the board for the entire worksheet, because I have to scroll down, which means I'm erasing these shapes. But you have it, it's on the top of your paper, and I would assume that you would refer to it. Okay. Yes, that's good. Okay, now we're going to put this into practice. All right, great news, everybody. All these segments are equal. The hypotenuses are equal. The baseline segments, those two are equal as well. So all of this, 1, 2, 3, 4, 5, 6, I mean, you're just going to be saying that the sides are equal to each other because they were created by a perpendicular bisector and a line going through a segment. So it follows that on number 1, I'm going to say 7x plus 24 equals 13x minus 48. You're more than welcome to use calculators. So class, if you want to come up and grab these, those of you that are here, ladies and Riley, grab one because you'll be using it a lot today. I don't want you to use your cell phones. I want you to use a calculator. So just do the math, guys. Can you do a double? Like if I minus 7x, but then I also said add 48 to the left. It's like double work in one step. I don't know, maybe you can. Because then I've got 72 equals 6x, and it just saved me a whole step. Antonella, please, I missed it. Please come on time.
I got kicked out, sorry.
Oh, you did? Okay, that's fine, thank you. Anyways, divide. It goes in 12 times. Do you guys have your 12s memorized? All I have to find is the value of x. I'll do 1, 3, and 5. You do not have to do 2, 4, and 6 on your own. Because it's all the same thing. Or no, I'll skip around. Let's see. All the left side are the base. Okay, let me do number 4. Just because these were the hypotenuses. And now I want to do one with the base. Number 4, 2x plus 11, 14x minus 37. Remember how these are equal? Because they are created by a perpendicular bisector, DG. So we're doing number 4 right now. Set them equal to each other because they are congruent. 2x plus 11 equals 14x minus 37. Seem nice enough? So I'm doing number 4 now. And I got 48 equals 12x. Divide both sides by 12. X equals 4. This is 2-step equation practice. Look, we're back in algebra 1. Okay? Stay with me because I still have a whole nother backside to go through on notes. So I did number 1, I got x equals 12. I did number 4, I got x equal 4. Okay, here's the plan now. Everybody on Zoom, I want you to do number 5. Everybody in class, I want you to do number 6. Everybody on Zoom, you are right now doing number 5 on your own. Go for it. So, Zoomers, you had to do number 5. And what's the answer? People on Zoom to number 5.
X equals 14.
Thank you. Did you read the directions and see that it asked you for AB? So if I know that X is 14, in order for me to find the length of AB, I need to plug 14 back in. But guess what would happen on a multiple choice test? A teacher might give you 14 as an option just to see if you're really paying attention to what you're doing. And some kid is going to pick A. Don't be that kid. So since they're equal, I can just plug it in for one of them, right? And double it. I don't know, 70 minus 11, 59. 59 is the 1/2 of AB, right? 118. AB equals 118. So then you'd have 118 as your other choice. All right. In class, you guys did number 6, and you set it up like this. What did you get for the answer for X equals, class? Zoe?
X equals 20.
X equals 20. Do you guys agree? 20? But it asked me to find JK. Okay, well, JK is just one of the sides. So 6 times 20 minus 26. Okay, I did it in my head. Elisa? 94. In case you didn't know what I did or what Elisa did, plug in 20 in for JK. 6 times 20 minus 26. So pay attention to the directions is the moral of the story here. That's a perpendicular bisector. It creates lots of congruent parts. The hypotenuses, the base legs, the base sides, and of course the reflexive property. If you had to do a proof, there'd be the reflexive property in the middle. So that's perpendicular bisectors. I am now moving on to angle bisectors. I believe it was your period that asked me about a week ago-ish, what's the difference between definition of bisector and angle bisector theorem? And I checked it to make sure that I was going to say the right thing. And this is exactly what we found. Angles are created from a point. So here we go. If a point is on a bisector of an angle, that would be like point D. Point D. If point D exists and it is on the line, oh, look, guys, this is a ray. Okay, hold on. Let's do it like this. Let's keep it consistent. So the first thing I know is that I have a point is on the angle bisector. Okay. Then this point is equal distance from each side of my angle. And hey, it's going to make a 90-degree angle. So you're going to create a 90-degree angle line, because I obviously could make a line that goes like this. I'm going to erase it as soon as I draw it. But couldn't I make a line that goes like this? Oh, look at that. But even those two lines, they're equidistant. This point D, I can go, oh, look, it's there. But those two lines I just drew, they're equidistant. So the whole point of this is that I'm going to draw my line just so, and it's going to make a right angle. Okay, Now these two little segments that I made are perpendicular. AB and BD are perpendicular. And AC and CD, they're perpendicular, right? So I'm going to say that BD is congruent to DC. BD is congruent to DC. BD is congruent to DC. A point is on the angle bisector. The point is equidistant from the angle sides and you need to draw it so that it's perpendicular to the angle sides. So it's this line in the middle of an angle. I'm drawing an angle, and then I'm going to draw a line in the middle that cuts the angle in half perfectly. Check this out. I mean, you notice this, right? Angle bisector. That's the angle bisector theorem. I start off with a line that cuts an angle in half. And then I can draw equal segments off that point. The converse says the opposite. The converse says that I already know that the point is equidistant from the sides. A point creates two segments that are equidistant. Equidistant, and of course they're going to be perpendicular. And perpendicular. So first I have two perpendicular sides. Two perpendicular like lines. Sorry, that doesn't look very good. They're created off of point D. Then I know that because they're the same length, the opening, like I have this thing, oh my gosh, I can't even get it. Compass, it's cool. It's for when I used to have a chalkboard in my room, I kid you not, a piece of chalk would go in here. And you could draw perfect circles, right? A compass, this is awesome. I can't put a whiteboard in it, whiteboard marker in it, but right now, here's point D. It makes a line that's equidistant, right? It also is the same distance to that. The opening is exactly the same. The opening that is created creates two equal angles. See that? My angles are equal. That's the converse of step 2, which I'll have to the segments are on the angle bisector. Wow, I'm not writing very nicely down here, sorry. The segments are on the angle bisector. So AD bisects, ray AD bisects angle BAC. The measure of angle BAD is congruent to the measure, is equal. It's the same exact size. Everything about it is the same. Equal to the measure of angle CAD. Two equal angles are formed. Okay, all that is there. Moving on. Okay. I have two equal segments and I have two equal angles. Just remember when you're drawing angle answers to put the degree sign, please. I want you to use the correct notation in geometry. That's important. Let's just do 3 of these, okay? Let's start with 2. Why not? Started with 1 last time. You guys, obviously my angles are going to be equal. 5x minus 11 equals 8x minus 41. I always move the smaller x over because I want to have a positive variable. So I'm going to move this 5x over so that I don't have to worry about like a negative something. Minus 41, but then I plus 41. Negative 11 plus 41 is positive 30. 30 equals 3x. All I had to do was find the value of x. No problem. Number 2 is good. I'm going to now look at number 3. Can you all please look at number 3? Somebody, can you tell me how to set it up? Yeah.
You do 13x minus 4 equals 6x plus 11.
Good, but once I get my x, I still have to plug it into AD. Thank you, Jenna. I'm going to subtract the smaller variable first. I think that is an excellent method to use. What? Did I do something wrong?
I think it's 8x.
Where?
8x.
Oh, okay.
My bad.
That's fine. It is jammed in because it looks like the font is all pushed together, you know? So I know that x equaled 5, but in order for me to find AD, 13 times 5 minus 4. 13, 26, 39, 52, 65?
Is it x equals 3?
I don't know. Am I doing it wrong?
Yeah.
Ay, ay, ay. It is. I know how many times 5 goes into 15. Man, I'm not paying attention. I'm trying to rush because I'm scared because I have like 6 minutes left. 13 times 3 minus 4. 13, 26, 39. 39 take away 4. AD equals 35. So this lesson should be a simple lesson for you, where you're setting things equal. Maybe you have to solve and figure out how big an angle is or how big a side is or something. Okay, on your attached worksheet. Scroll down. The homework is a part of the PDF that I put up on Google Classroom. Okay, for homework tonight, the only thing is that like number 7 is like, woohoo. So why don't we do this? I do want you to do 7, so I'm gonna have you do the odds. 1, 3, 5, 7, 9, 11, 13. You have to do number 7. Okay. And then tomorrow I am gonna teach you another lesson. So we are learning tomorrow, just so you know. Do you guys have tests in other classes tomorrow?